Good morning, my dear students. I hope you all staying at your home. I am from Science Department. Now I am going to teach Physics subject. First I start chapter 1, Matter. Already we learned about matter. Last year we studied about matter. What is matter? Do you know? Define matter. Anything that has mass and occupies space is called matter. Anything that has mass and occupies space is called matter. Then kinetic theory of matter. In the last class we studied kinetic theory of matter. We know about the kinetic theory of matter. It has four important points. Then force of attraction between the particles. It has two types, force of cohesion and force of addition. Today we are going to see about states of matter. Today we are going to see about states of matter. According to the arrangement of particles in matter, the force of attraction between the particles, that means interparticle attraction, the space between the particles, all matters are divided into three categories. These are the three categories: solids, liquids and gases. According to the arrangement of particles in matter, the force of attraction between the particles and the space between the particles, all matter is divided into three categories. What are they? Solids, liquids and gases. Do you know the examples of solids? Book, box, eraser, etc. Then few examples of liquids: milk, oil, then water, etc. Then gases: oxygen, carbon dioxide, hydrogen, etc. Okay. Now we are going to study about solids. Okay, solids. Solids have a definite volume and definite shape. Solids have a definite volume and definite shape. In solids, the interparticle attraction is very strong. Okay, interparticle attraction is very strong. Therefore, the interparticle space is the least. It has interparticle attraction is very strong. So, the interparticle space is the least. The particle vibrate in fixed positions. The particles vibrate in fixed positions because solids are not easily compressible and expand very little on heating. It is negligible. Okay. Solids have a definite volume and shape. In solids, the interparticle attraction is very strong, so that the interparticle space is the least. Next, about liquids. In liquids, it has definite shape but no definite, it has no definite shape, it has definite volume. Okay, liquids have a definite volume and no definite shape. They take the shape of the container in which they are kept. Okay, for example, when water is poured in a glass, it has the shape of the glass. When it poured in a pan, it takes the shape of the pan. If you throw water on the floor, you will see that it spreads on the floor. This shows that the interparticle attraction in liquids is not as strong as than the solids. So that the interparticle space in liquids is more as in comparison of solids. Liquids have a definite volume but no definite shape. They take the shape of the container in which they are kept. Then the interparticle attraction in liquids are not as strong in comparing that solids. The interparticle space in liquids is more as in comparison to liquids. Next, on heating, liquids expand more than solids. As liquids have a definite volume, they cannot be compressed easily. Next one is gases. Gases do not have definite shape and volume. Gases do not have definite shape and volume. The particles in gases are very loosely packed. The particles of gases are The particles in gases are very loosely packed. Therefore, the interparticle space in gases is much more as compared to liquids. Also, the interparticle attraction is least in gases. Okay, gases do not have definite shape and do not have volume. Do not have definite volume. The particles in gases are very loosely packed. The interparticle space in gases is much more as compared to liquids. Next, gas particles move freely at high speed. So, when a gas is kept in a container, the particles spread out in all directions as they hit each other and the container walls. So, the end space inside the container is filled by the moving gas particles. Okay, now we studied about states of matter. These are what are the states of matter? Solids, liquids, and gases. Do you know fourth state of matter? In the last class we studied about plasma. Is it? Yes, plasma is the fourth state of matter. It is an ionized gas in which both ions and electrons. It is created by providing enough energy to a gas so that some of its electrons leave their atoms. So, plasma is overall neutral but contains positively charged ions and negatively charged free electrons. Where we will find the plasma? Stars are mostly made of plasma. At a high temperature on the stars break up the atoms and create plasma. What is the fourth state of plasma? Plasma is the fourth state of matter. Plasma is the fourth state of matter. Stars are mostly made of plasma. Where we will find? In the stars. The high temperature on stars break up the atoms and create plasma. Okay, next topic is differences between solids, liquids and gases. Differences between solids, liquids and gases. They have 8 properties. Okay, they have 8 properties. What are the 8 properties? Volume, shape, fluidity, arrangement of particles, movement of particles, interparticular spacing, interparticular attraction and compressibility. Okay, these are the properties of states of matter. First one is solids. Solids, liquids and gases. First one is solids. Volume. In solids, they have definite volume. Solids have definite volume. Liquids have definite volume. Gases do not have definite volume. Gases do not have definite volume. Next property is the shape. Solids have definite shape. Liquids have no definite shape. Gases have no definite shape. Next one is fluidity. Solids cannot flow. Solids cannot flow. Liquids can flow. Gases can flow very easily. It will be move all the directions. Next, fourth one is arrangement of particles. Packed very tightly in a definite pattern. Okay, it is tightly packed. Solids are tightly packed very tightly. Next one is loosely. Liquids loosely packed. Gases very loosely packed. Fifth one is movement of particles. Movement of particles. Particles of a solid cannot move freely, can only vibrate in their position. Particles of a solid cannot move freely. Already we studied this interparticular spacing and attraction about that. So, it cannot move freely. It is closely packed. So, solids cannot move freely. In liquids, move freely. Liquids move freely. Gases, constant. Particles are in constant or random motion. Constant or random motion. That means it will be move all the directions. It will not moving straight line. Next property is the interparticle spacing. Interparticle spacing. In solids, interparticle space is very less. In liquids, it less. Gases, high. Intermolecular space is very high. Already we studied about this. Next, interparticular attraction. In solids, it's very high. In liquids, low. In gases, very low. Next, compressibility. So, in solids, negligible. Negligible means so small. What is the meaning of compressibility? It means reduced in size by pressure. Because of any pressure, it will be reduced in size. So, in solids, negligible. That means so small. Next, liquids. Liquids also negligible. Next, gases, high. Okay, these are the properties of solids, liquids and gases. Differences between the solids, liquids and gases. Okay, next topic is energy involved in change of state. Energy involved in change of state. Matter can change from one state to another by observing or releasing energy. Matter can change from one state to another by observing or releasing energy. Next one is, what is the latent heat? What is the meaning of latent heat? The amount of heat that observed or released when a substance undergoes a change of state without any change in temperature. Latent heat means the amount of heat observed or released when a substance undergoes a change of state without any change in temperature. It's called latent heat. That means from solid to liquid, liquid to gas, gas to liquid, liquid to solid. It will be change the state of matter without any change in temperature. That is called latent heat. When matter is changing state, there is no change in temperature. This is because all the heat observed or released by it is used for the rearrangement of particles. When matter is changing state, there is no change in temperature. This is all the heat observed or released by it is used for the rearrangement of particles. Next one is specific latent heat. What is the meaning of specific latent heat? If the amount of matter changing state is a unit mass. If the amount of matter changing state is a unit mass. We use the term specific latent heat for the amount of heat observed or released. The amount of heat observed or released. The SI unit of specific latent heat is joule per kilogram. What is the SI unit of specific latent heat? Joule per kilogram. Next topic is latent heat of fusion. Latent heat of fusion. What is that? The amount of heat observed or released when a substance changes from solid to liquid. S2L means solid to liquid or from liquid to solid without any change in temperature. It is called latent heat of fusion. The amount of heat observed or released when a substance changes from solid to liquid or from liquid to solid without any change in temperature. Latent heat of fusion is used both. That means for the amount of heat observed when a substance melts or the amount of heat released when it freezes. Okay. Next one is the specific latent heat of fusion of ice is equal to 336 into 10 power 3 joule per kilogram. What is the specific unit? Specific latent heat of fusion of ice is equal to 336 into 10 power 3 joule per kilogram. This is latent heat of fusion. What is the SI unit of specific latent heat? That is joule per kilogram. That SI unit we have to add here. Okay. Latent heat of fusion. Next topic is latent heat of vaporization. Latent heat of vaporization. What is the definition of that? The amount of heat absorbed or released to change a substance from liquid to gas or from gas to liquid without any change in temperature. Do you know the difference between latent heat of fusion and latent heat of vaporization? Here, liquid to solid to liquid or liquid to solid. Here in the vaporization, liquid to gas or gas to liquid. The amount of heat absorbed or released to change a substance. That means liquid to solid or solid to liquid. That is the changes. To change a substance from liquid to gas or from gas to liquid without any change in temperature. The amount of heat from here, the specific heat of vaporization of water. Okay, the specific latent heat of vaporization of water is equal to 2260 into 10 power 3 joule per kilogram. What is the value? The specific latent heat of vaporization of water is equal to 2260 into 10 power 3 joule per kilogram. Next, the amount of heat released or absorbed by a substance. Is it during the phase change? We will use one formula, that is M into L. What is the formula of this? The amount of heat released or absorbed by a substance during phase change. M into L. What is the M? M is the mass of substance. M is the mass of substance. Then L is the specific latent heat of fusion or vaporization. L is specific latent heat of fusion or vaporization. Here M is the mass of substance, L is the specific latent heat of fusion. What are the topic we studied? First one is latent heat. Next is specific latent heat. What is the SI unit of specific latent heat? Joule per kilogram. Next, latent heat of fusion. Next, latent heat of vaporization. Latent heat of fusion. The specific latent heat of vaporization of ice is the what is the value of that? 336 into 10 power 3 joule per kilogram. The specific latent heat of vaporization of water is equal to 2260 into 10 power 3 joule per kilogram. Next, in this topic we have some advantages. Advantages of high latent heat of fusion of ice. What is the first sentence? Means soft drinks are cooled by placing them in ice rather than water at 0 degree centigrade. Next one is snow melts slowly on the mountain slopes in summer as every gram of ice needs 336 joule of heat energy to melt. Next one, water bodies such as rivers and lakes do not freeze suddenly in winter as every gram of water has to release 336 joule of heat energy. Next point is it becomes bitterly cold in cold countries when snow starts to melt as a lot of heat energy is absorbed from the surroundings for the melting of snow. Next, ocean currents carry icebergs for a long distance. Okay, these are the 5 points of advantages of high latent heat of fusion of light. Fusion of ice. Okay, next one is effects of high latent heat of vaporization of water. Burns caused by steam are more serious than burns caused by boiling water. Next one is water from lakes, rivers and seas does not vaporize rapidly. These are the effects of high latent heat of vaporization of water. What is the latent heat? The amount of heat absorbed or released when a substance undergoes a change of state without any change in temperature. Okay. Today our class is completed. Next topic we will see the next class. Thank you children.